Hi, my name is Andy Redmond, and I am the Director of America's Solution Engineering here at Progress Software. With my present role at Progress, I lead a team of highly skilled solution architects who are really focused on giving customers a forensic lens into network traffic for the express purpose of assisting leaders in making really wise decisions about cybersecurity and network performance issues. I'm thrilled to be joining you with my colleague Frank today to share with you what we here at Progress believe to be the absolute gold standard in cybersecurity network detection and response.
Hi, my name's Frank Cotto. I'm a solutions architect with Progress Software, and as Andy mentioned, we are really looking forward to sharing this presentation with you today, so let's get to it. Held for ransom, to pay or not to pay, that is an option. Our goal today is to take you through the stages of a ransomware attack and to highlight how Flomon's anomaly detection system detects and responds to ransomware attacks from initial access all the way through to a ransom demand. We're going to hit the ground running and start by digging into the attack scenario. We'll then go through those stages I mentioned of a ransomware attack while demoing Flomon's detection and response capabilities at each stage. I'll then hand it over to Andy, who will be taking us through the complete picture and a brief technical overview of Flomon. So let's get started. The attack simulation and detection we are going to take you through today was in fact inspired by a real customer case and replicated within our lab. Here's the real-world attack scenario. You decide to take your laptop with you to a local coffee shop to get some work done. You connect to the shop's Wi-Fi, where malware makes its way onto your laptop without your knowledge and starts to run in the background. When you get back to your office and connect your laptop to the company's network, the attack kicks off. The malware running in the background on your laptop can detect that you have connected to a new network, and it starts to scan the whole network using various methods. It discovers two devices, a client machine with RDP running on it, and a server with Samba running on it. After discovering these services, the malware performs a technique called password spraying. It tries notoriously known passwords and username combinations. The malware then tries to scan the target with RDP running on it to determine if it is vulnerable to a known exploit called Bluekeep. It is, so the malware exploits this vulnerability and gains system administrator privileges. The malware then runs a keylogger on the victim machine and takes screenshots. As a result, the attacker can discover credentials to the target Samba network drive. The malware then downloads a file from the Samba drive. The malware then exfiltrates this file using the ICMP protocol to exfiltrate the data from the victim to its command and control server. After the file is exfiltrated, the malware encrypts the files on the Samba drive, and the ransomware negotiations begin. Here's a breakdown of the acting devices and objectives of this specific ransomware attack. As I mentioned earlier, this attack is our real customer case, and the full scenario was replicated inside of our lab environment. The actors include a compromised device, 192.168.1.50, a Samba server, .2, and an RDP server, .3. The objectives, of course, are to exfiltrate sensitive customer data and encrypt that data while then asking for a ransom. Now that we are familiar with the attack scenario and the architecture, let's dive a little deeper and have a look at how the attacker's network activity is detected by Flomon at every stage. At the start of the discovery phase, the malware starts its horizontal ARP and vertical TCP scanning in order to map out all of the network resources within its reach. Flomon identifies the vertical ARP scan being carried out by the infected device via its scan detection methods. In its event generation, it highlights key information such as the event type and details, timestamps, event source IP and MAC address, target IPs, and all of the flows that triggered the event. Next, Flomon identifies the horizontal TCP SYN scan that the malware runs in order to identify available services running on 3 discovered targets. In addition to identifying the malware scans individually, Flomon detects the diverse communication attempts from the infected device and highlights all of the endpoint IPs and ports within the network that it is attempting to communicate with. Having the ability to also generate signature-based IDS incidents, Flomon triggers a Samba potential scan or infection IDS incident. At this point in the attack, The malware has discovered two devices, a client machine with RDP running on it and a server with Samba running on it. Now that the discovery phase has come to an end, the malware begins its attempts to gain access to services it has identified are running within the environment. It first attempts to gain access to the Samba server and later the RDP client via the password spraying technique, notoriously trying known passwords and username combinations. Though the malware is unsuccessful, it triggers two events on Flomon. The first event is a Samba protocol dictionary attack brought on by the large number of attempts to access the server over port 445. The second event is an RDP dictionary attack brought on by the large number of attempts to access the client machine over port 3389. Moving laterally through the network, the malware tries to determine if the target client running RDP services is vulnerable to a known exploit, Bluekey. The client is indeed vulnerable, so the malware exploits this vulnerability to gain system administrator privileges. The malware then runs a keylogger on the client machine and takes screenshots with which the attacker can discover credentials to a Samba network drive. Since this operation is performed locally, it does not generate any network traffic, therefore it is not on Flomon's radar. Deciding to leverage the Bluekey exploit to gain access to the RDP client, the malware's network behavior triggers the IDS incident possible Bluekey. Furthermore, though we could not capture the local traffic associated with the malware leveraging a keylogger to gather credentials and access to a Samba network drive, we are able to identify when the malware uses its access to download a file from the Samba drive via a high transfer event. The high transfer behavioral method detects the usage of a data link by a user to move large amounts of data exceeding a single IP data volume threshold. The malware then begins to exfiltrate the downloaded file from the victim's machine to its external command and control center server via ICMP. ICMP is not a standard protocol used for transferring data, and in detecting the presence of payload in ICMP traffic, Flomon triggers the ICMP anomaly event. We have also configured this Flomon instance to automatically run and store a packet capture whenever it detects payload within ICMP. These captures are essential in data exfiltration scenarios as they provide the ability to determine which files have been exfiltrated from the environment. These captures can oftentimes determine the severity of the ransom that is to come. The action of exfiltration to the malware command and control center also triggers a Flomon blacklist event due to the destination being a known malware command and control center. See, Flomon maintains a reputational database which consists of known malicious IPs and command and control centers. Lastly, the exfiltration traffic triggers an upload event, which detects when a device excessively uploads data outside of an allowed network segment. And in the final stage of this attack, the malware encrypts the files on the Samba drive once they are safely exfiltrated out of the network. The encryption of these files on the Samba drive triggers an SMB traffic behavioral pattern event on Flomon, notifying SecOps engineers a ransomware attack has successfully been carried out. The result is the same at the completion of every successful ransomware attack. The attacker demands to be compensated in return for your sensitive and now encrypted data. Flomon was able to detect the malware's anomalous behavior as soon as it started to communicate on the network. The alerts it provides could have led to a SecOps engineer stopping this attack in its infancy. Due to Flomon's flexible ability to integrate with perimeter and endpoint security solutions, this attacker could have been quarantined in its discovery phase via an automated approach. There is a price to pay for lacking powerful network detection and response. And with that, I'm going to hand things over to Andy to take us through the complete picture and brief Flomon technical overview.
Now that you've gained a really good understanding from Frank about why we believe Flomon is truly the gold standard in network detection and response through sharing the demo, let's shift our focus slightly so that you'll gain a high-level overview of the actual Flomon architecture and what's included in the product. Now, one of the key aspects of the Flomon product is that because of how it will be deployed and implemented within a network architecture, the consumer of Flowmon will successfully achieve an historically challenging objective, and that is to gain complete visibility of every single communication, literally every flow of traffic in the environment. This forensic level visibility uniquely enables the network and security operations personnel to prevent network issues and breaches and respond immediately to security threats with a single network traffic performance and security analyzer. Specifically, security operations personnel will get a complete, holistic picture of an attacker's activity, considering that Flowmon sees every flow of traffic. With this level of visibility, every step or action an attacker makes in a network environment is tracked, documented, interpreted, and subsequently mapped directly to the very well-known MITRE ATT&CK framework. This MITRE ATT&CK framework carefully details an attacker's process of penetrating a network and then the systematic approach leveraged by that attacker to find the high-value data and exfiltrate that data prior to deploying ransomware and crippling the business organization. As noted, Flowmon maps attacker activity to the MITRE ATT&CK framework, which provides specific event visibility on a timeline. Flowmon will, in real time, show a compromised network device's communication with well-known command and control blacklisted IP addresses. It will identify when an attacker tries to scan for high-value data storage, and it will show brute force password spraying or guessing to try and elevate authentication privileges to give more access to resources, etc. You'll gain the critical insight into every aspect of an attack and know precisely when an attack started and the process by which the attacker is seeking to cause harm. So, what's included in the Flowmon product portfolio? Let's take a look. The foundation of the Flowmon product is forensic level network detail that focuses on enabling a few critical areas. It enables network operations personnel with a tool set to capture traffic and root cause network performance issues incredibly quickly and with automated analysis as well. It leverages AI-driven behavior analysis and anomaly detection to preemptively mitigate the most subtle exploits before they have a negative impact. And it delivers key insights on app and database performance, combined with workflow automation for addressing suboptimal application experience. At the heart of Flowmon is the Flowmon collector. In this diagram, the collector ingests network flow data from a variety of network devices, and more importantly, the Flowmon probe with enriched flow data. The Flowmon probe is bar none the most powerful NetFlow generator on the planet, enabling the very best insight into what's happening on the network as it relates to performance issues and cybersecurity attacks. As noted previously, the Flowmon collector enables network performance monitoring and diagnostics, cyber-related network detection and response, and application performance monitoring down to the individual database queries to baseline if there's a network issue or a database issue. The Flowmon collector is the heart and brain of all network performance and cyber-related security attacks, and more importantly, how to actually mitigate these issues immediately. Neil McDonald, a very distinguished analyst with Gartner, has said that detection and response are more important than blocking and prevention. Pretty incredible and insightful comment from him. Not only do we agree with this statement, but we've actually built the Flowmon product specifically to enable this notion of NDR, or network detection and response. It's who we are. As noted previously, Flowmon has a broad set of methods and algorithms that categorically and empirically map an attacker's threat steps in a network directly to the proven MITRE ATT&CK framework. Flowmon knows what they're doing and how they are doing it. So Flowmon leverages key network telemetry, reputation feeds, IDS or intrusion detection signatures, and full packet data as the input data to its information. There are over 200 proprietary algorithms and 40 plus methods that leverage machine learning, adaptive baselining, user behavior analysis, heuristics, reputation data, and signatures to tool security operators in order to make wise decisions. Flomon is keenly focused on results based on security events, relevant telemetry, as we've discussed, forensic capture data and analysis, CVE references as to well-known threats, and automated responses. When it comes to a joined-up effort, Progress, together with the team at Dell, has paved the way for a solution that is innovative, provides a multi-layered security approach, and brings a whole new dynamic in terms of detection as well as protection inside the Dell UDS world. Flomon, with its capabilities to detect the anomalies, which we've spoken about, coupled with Superna, which is one of the additional products in the Dell portfolio, provides protection for the data layer. You can see for the diagram here that there is a collective potential to bridge the gap when it comes to detection as well as protection. Flomon helps to detect the potential breach, while Superna protects against any potential manipulation of the data within the Isilon cluster. Ransomware would potentially be a big issue here, but with the ability to detect such malicious intent, block the request, and to protect the Isilon cluster from being encrypted as well as replicated, the solution is adding significant value here. So let's go into this in a little bit more detail. A Flomon probe has been deployed, which is collecting log information from network devices, such as switches, firewalls, and routers. This detail is then shipped to the collector and rendered in the Flomon management console. An attempt to breach the network defenses by the bad actor, Flomon detects such threats, and we can send an API call directly to the participating partner, who in this case is Smart Air Gap, which shuts down the potential for a breach, alerts the admin team, as well as creating a snapshot of the data. Superna's integrated user behavior detection Smart Air Gap ensures data sync and replication is suspended when suspicious user behavior is detected on the source production cluster. In short, detection is enabled by Flomon, protection at the storage level is maintained by Superna, and a response is handled by both vendors in several ways, such as an alert to the admins, an API call to the storage layer, and further protective measures can be kicked off to start the lockdown and prevent issues such as ransomware encryption. In order to have effective network threat detection, which we firmly believe is the absolute best approach for not only discovering, but mitigating cyber attacks, you need the right tools in the toolkit. You need the right framework, which is the proven MITRE ATT&CK framework, to map an attacker's steps. And you need the right methods to understand what an attacker is doing. And you need the right information to tool you with the critical knowledge to be wise and to be successful. You will achieve effective network threat detection when you deploy Flomon in your network.